My name is Panos Georgiakis. I'm based at the University of Wolverhampton in the UK. And as Fanny suggested, I'll be giving an overview of the Frontier project before going to the workshop. So every sort of participant gets some good idea about Frontier and the activities and also the innovations that we are trying to achieve as part of the project. So the full title of the project is Next Generation Traffic Management for Empowering CAVs Integration, Cross-Stakeholders Collaboration, and Proactive Multimodal Network Optimization. So quite a mouthful, but it's mainly about sort of designing and sort of investigate, if you like, the traffic and network management system for the future. Fanny mentioned a couple of things about Frontier already. So it's a Horizon 2020 Research and Innovation Action. It started 1st of May, so we are now in month 8 or 9th of the project. We are 19 partners from 8 different countries in Europe, and the approximate sort of budget is 5 million euros. So it's quite a big project with quite a few different sort of partners with different expertise also, and hopefully we'll have some good outputs to present after the end of the project. So in terms of Frontier, at the sort of proposal stage, when we actually started to conceptualize the project, we tried to find a few sort of challenges at the moment, or opportunities, if we see those in a different way at EU level, and try to build the project based on those. So one of the things that came across was the sort of the upcoming deployment of CAVs. And there's a bit of an uncertainty about this, when this will take place, and in sort of, let's say, in real environments. But of course, in terms of traffic management, one of the things that we would like to investigate is how this introduction of CAVs into the traffic will actually affect the services. And of course, this introduction of CAVs will probably take place progressively. So we're going to have, let's say, a low level of penetration at the beginning, and that will grow as over the years, and that will create sort of different circumstances of the transport network. Another big sort of talking point and research area nowadays at EU level, of course, is shared mobility services, and there is this drive to move away from private cars and sort of promote all these initiatives like MAS. So another area of Frontier is to sort of look at those sort of initiatives from the demand side as well, and see how this will affect, again, network management services. The complexity of the current systems also is an area of work of Frontier, and of course we have many different services and systems that work in different areas of transport. Some are on the supply side, some are on the demand side, and they're very dynamic, and they have different sort of characteristics. So how can we integrate all this together in a single ecosystem, and then use, let's say, those to provide traffic and network management is an important area of work of Frontier. Cooperation is something that was very prominent, and how the different sort of organizations can cooperate as part of network management. And there's, again, a lot of initiatives and at European level to sort of promote cooperation. So this is one of the main, let's say, areas of work of Frontier, to look at all those requirements that will underpin the cooperation between the different stakeholders and different actors when it comes to network management. And indeed, one of the workshops later today will actually be looking in this area of work. Digitization, of course, Internet of Things, and this deployment of all these new technologies have created some sort of inconsistencies in terms of the maturity of different systems or different cities in EU. So one of the outputs of the project will be this sort of the generation of a smart road infrastructure index. So we can say, okay, this particular area in this city in Europe has this level of maturity in terms of technology, and then based on that we can sort of assess which services are ready to be deployed, etc. Quite similar to the level of automation of cabs, starting from level 0 to level 5. So something similar, but more on the infrastructure side. So then we can assess, if infrastructures are actually ready to accommodate the needs for cabs. And the last one, again, very important, and that goes back to this sort of concept of cooperation between different stakeholders. There's this concept of a main player or an orchestral conductor, as we found in one of the EU documents, about an organization, an entity that will actually supervising and orchestrating all the different services. And in some cases, this is well defined. So, for example, again, mobility as a service, you have the sort of mobility as a service operator that has this role to sort of coordinate all the different service providers. But maybe on the network and traffic management, let's say, arena, this is not very clear yet. So if you have many traffic control units and public transport operators to sort of work together, it's not very clear how this will take place. So again, this is one of the goals of Frontier, to find those synergies and conflicts and ideally come up with some operational and business models to make this collaboration a reality. So these are the high-level goals, if you like, of Frontier. Again, trying to sort of address some of the needs that are quite prominent nowadays at EU level. And the vision of the Frontier is to empower a seamless transition to an autonomous and integrated transport management for future mobility services. And again, the idea is really to see how we can bring some autonomy, not only to the vehicles, because that will eventually, of course, happen, but also to the services related to network management. Can we automate some of those? In terms of the objectives, and these objectives are actually aligned with the sort of goals that I mentioned earlier. So, is to design an architecture to address these sort of requirements for next generation multimodal network and traffic management systems. And then we are following a sort of model or a methodology, which I'm going to explain a bit more later as well. But it's what we call the observe, orient, design, and act methodology. So at the observe layer, the idea is to have all the necessary systems in place to be able to understand the current and future state of the network and on the services. So this is on the data side. So try to integrate data from different sources. Again, at the once we actually get and analyze this data, is to allow the generation of different scenarios that may happen in the future, and then try to see how we can optimize the different services based on those scenarios, both at the demand and at the supply side. Then is to develop the necessary services to support decisions, and then those decisions can actually take place at different levels. They can be at the system level, or they can be at the vehicle or user level. Then once those decisions are taken, then is the action stage. So we provide the mechanisms for, or ideally would like to provide the mechanism to sort of deploy those decisions and then try to assess the impact of those decisions in network and traffic management. Of course, underpinning all these sort of more technological, let's say, objectives, we are aiming to develop the necessary multi-actor operational and business models to underpin this sort of integrated traffic management approach, because there's going to be a number of different actors and stakeholders working together, and having those models in place is going to be a very important aspect of Frontier. We have a number of demonstrations, and again, I'm going to explain those very briefly later on. So we're going to try to demonstrate the solutions we develop in real environments. And of course, try towards the end of the project to disseminate all the results and try to see how we can sort of incorporate those results and use them, for future, let's say, policy making, and of course at the project level to see how we can exploit some of those results and hopefully become products into the market later on. So these are the objectives of the project, and now I can go and talk a bit more about the concept. As I mentioned before, we have this sort of layered approach. So we have this observe, orient, design and act. So at the observe layer, we have a number of different services and systems where we try to integrate data. So we have data from many different sources. Those can be from anything related to traffic, so sensor data, floating car data, data from public transport services, etc. But we can also have maybe data external to transport. So, for example, weather data or maybe data from social media, etc. So, we try to sort of have this sort of big data architecture that will allow the integration of all this data, the harmonization of the data, and making the data available for some more high-level services. Oops, I don't know why. Okay, so at the Orient layer, we are looking at two different approaches. We have a data-driven, let's say, services. So we receive the data and then we try to provide some sort of intelligence about the network. And we can do that in a data-driven approach. So we have algorithms and models related to anomaly detection, predictive analytics, and traffic state estimation, etc. So we try to understand what's going on the network in real time in terms of supply and demand. But also we have a simulated, let's say, environment. So the idea here is to try to use simulations in parallel with data-driven approaches to get a better estimation about the future of the supply side and how it's going to look like. And again, I'm gonna sort of talk about this a bit more later in the presentation. So once all this data have been analyzed and we know what's going on the network, the idea then is to provide some sort of decision support. And as I mentioned earlier, this decision support can be at the system level. So it can provide some, let's say, potential response plans that can be undertaken by traffic management centers based on the effectiveness of each of those plans. We can maybe provide some sort of a decision about maybe the provision of on-demand services and put some on-demand services because now from the public transport perspective, because the demand in some areas is very high. So things like that. So within this sort of layer, we have this decision support for different stakeholders. And then once we identify what is the best, let's say, action to take, then we sort of deploy and try to propagate this action into the network. And we can try to do this in many different ways. So, for example, on the user side, we can use nudges to proactively ask users to maybe take a decision that will benefit themselves, but also the network in its entirety. And of course, we the propagation can happen in stages. So maybe we need to inform a few users first, and then maybe we inform another group of users, etc., to find what is the optimal way to do that. So this is, if you like, the overall approach and the different sort of ideas that we have in terms of realizing the vision of Frontier. And of course, here on the left-hand side on this sort of concept diagram, we have the living lab sort of area of work, and as part of that is to identify the requirements. And indeed, this workshop is part of this sort of requirement or user needs, let's say, elicitation activities of Frontier. So we would like to get experts' opinions on what we are doing and try to find what are the, let's say, needs that we need to address. And again, as a project, you always start with some ideas and you have your own sort of solutions to specific problems, but it's always useful and very sort of productive to get the opinions of experts in the field and try to sort of accommodate those as well. And here at the top, we have all the different sort of pilots and the areas that Frontier will actually be deployed, or the Frontier solutions, and we're going to talk about those now. So we have three themes in Frontier. The first one is about smart infrastructures and integration of CAVs. And again, those themes are actually the topics of the three breakout rooms later today. So this one will actually be looking at how CAVs can actually be integrated in the future, and look at concepts like centralized, decentralized control. How can we define dynamically the operational domains of CAVs, how the vehicle control can actually be transferred between the machine and the user. If there's any potential to use CAVs as traffic management devices, and also generate this sort of classification index for smart infrastructure. So this is one of the themes of the Frontier. The other one is related to multimodal mobility, passenger and freight, cross stakeholders collaboration. So in this one, we are looking on how different organizations can actually work together as part of network management, integration and fusion of information from different sources to be able to accommodate and support this decision making. Of course, look at the necessary interfaces that will allow the communication between those stakeholders, not only on the system level, but also on the human level as well. On the freight side, actually one of the areas of work is actually looking at freight in Frontier, and look on how we can sort of integrate different modes of transport, especially waterborne with road transport, to, let's say, improve the efficiency of freight operations. And also see how we can deploy response strategies, and how this can be done in a coordinated way across many different stakeholders. And the last one, I don't know why I may actually try to, sorry about that. It looks like my presentation is not in full screen for some reason. So I may quickly do this. I hope you can see my screen okay still. So the last theme is about network performance analysis for planning and policy making. So this area of work is related to the simulation and modeling aspects of Frontier, because many of the things that we're actually looking at in Frontier are not out there at the moment. So the penetration of CAVs is minimal. And of course, what we need to do is we need to look at how this, penetration of CAVs will affect, let's say, future planning and policy making. So an area of work within Frontier has to do with simulation and modeling, and not only for the future, but also for now. So, for example, what happens if we need to plan for a special event, and how we can again do this in a coordinated and integrated way. So these are the main themes of Frontier, and again, as I mentioned earlier, these are the themes of the sort of working groups that will follow my presentation. In terms of the pilot, we have three locations. We have identified three locations that are Frontier solutions will actually be demonstrated. The first one is in Oxfordshire, and in Oxfordshire we're going to be doing some trials with CAVs at Race, which is a test bed for CAVs in Oxfordshire, and within that we're going to try different sort of scenarios, and we can see how we can incorporate CAVs into the traffic management systems and integrate with traffic management system. And of course, there is a work to be done there in terms of allowing the, let's say, two-way interaction between CAVs and the control center, and also sort of try to fuse all the information that comes from the different systems. Then we have a pilot in Athens, and the main focus of the pilot in Athens will be the integration of many different stakeholders. So we have a number of public transport operators, and we have the highway operator as well, which manages the main, let's say, highway network in Athens. And within this pilot, we're going to try to see how the different organizations can actually collaborate together to provide efficient network management. And the last pilot, last but not least, in Antwerp, And this is the pilot that is more focused on logistics. And the main aim of this pilot is to see how we can actually take advantage of the waterways network in Antwerp to, let's say, manage the network, the road network in a better way. So there is waterways network that's not utilized fully, and we would like to see how we can integrate the road and the waterway network to provide more efficient logistic services. So 3 different pilots with different flavors, but again, each of those will have elements of those themes that I presented earlier on. So in terms of, I may have to, sorry, put that back into the presentation mode. Again, hopefully this is visible now. So in terms of the network management approach, this is, let's say, a picture that tries to incorporate all the different innovations of Frontier in one diagram. So we have this sort of autonomous network traffic and management engine that we would like to develop, and the idea of this engine is to look at different potential scenarios about the supply in the near future, and then try to come up with some response plans for each of those scenarios. Each of those scenarios may have different probabilities of being, let's say, enacted in the future. And the idea of this engine is to try to sort of come up with the different response plans. And scenarios can be generated based on different conditions of the network, or maybe different triggers. So, for example, an incident may generate or create, let's say, this, or trigger the need to identify those different scenarios. And we use simulations to try to, let's say, find the optimal response plan. So, have all these different scenarios. We try to simulate those scenarios based on different conditions and parameters, and then also simulate the different response plans for each scenario. So once a scenario is coming to realization, then we know which response plan will actually be more efficient for this particular scenario, and then we can try to deploy that response plan. So again, simulations is an integral and very important part of Frontier. Again, this is more on the operational side. And as I mentioned before, we have also simulations on the planning side. Then we have, again, a number of sort of innovations in terms of AI and demand management. So we're going to be looking at services and models to be able to, let's say, identify incidents. So if we find out that something on the network is not working as it's supposed to be, then that could actually trigger an alarm. On the demand side, we can actually be monitoring the different sort of services and find out maybe spikes on demand at specific areas of the network, and then try to react on those as well. So there is this sort of combination of supply and demand solutions and algorithms that we would like to develop to support the operation of our approach. Then we have a number of interfaces internally to the platform. And again, I'm not going to go into a lot of detail on the technical, let's say, specification of the platform, but the idea here is we're going to have this simulation environment, and we're going to have this sort of traffic management engine, and we need to somehow make sure that those two are actually working in parallel and the right interfaces are in place. We have a number of external entities and systems that we need to integrate, and these vary from ITS systems, but also control centers or systems that are actually existing now in control centers, because our solution will act as a sort of an integrator, let's say one layer above the existing system. So we try to integrate, we're not trying to reinvent the wheel in terms of traffic management, control centers, or public transport, let's say operators control centers. We try to integrate them together. And of course, as part of the integration, we're going to develop a number of external interfaces to allow this integration and allow, let's say, the collection of data, but also the interfacing between all those different systems.